maybe the all preparation, right? But anyway, hopefully they can catch up the content we'll cover today. You guys are here, that's good, because we are beginning chapter 5 today. Okay, let's finish chapter 3. We have already spent like 2 weeks on this chapter. You have learned so many different methods. And the latest model we have done together is called a simple linear regression model. And then we can see that's how to use the unemployment rates to forecast units sold, right? And there's some assumptions of this simple linear regression model, right? So we'll talk about first, you have to plot data before you jump to this model. Right? It shows there's a linear relationship, then you can test this model. But a simple plot doesn't mean it still satisfies all the assumptions. The first assumption is that the variation around the line are random. Okay, so that means, so if we see a model, let's say x, y, and then if this is our straight line, then your observation should be around this straight line, something like that. That looks pretty good, right? Those dots are not exactly in the line, but they're around. But what's kind of the problem? If the variation is not random, let's see. Okay, we fit a line, but let's see the variation. If those dots are the observations, well, maybe you still have a pretty good R square, but obviously it's like a curve should fit better for this pattern instead of a straight line. Well, it's already violates this assumption because the variation is not random. Right? First, always above the line, and then the middle part is below the line and above again. So it's not random. Second assumption is variation around the average value should be normal distributed. So you can't say, okay, the variation, let's think about that one. Okay, this one. So if you see something, right? See something here. Okay, so we fix this observation by the straight line almost in the middle of two parallel lines, right? That's what we fix as. But this variation has no normal distribution, right? It's very close to this line, there's almost no observation. Well, far away, no, but all the observations are in the middle range. Then we should have this concern. In fact, if the observation is like this, we probably need to have two lines to fix the data and find what's the difference, why they're different. We have to first divide the observation into two groups and fix it if you see something like that. But you know that, okay, this doesn't satisfy the assumption 2, so should raise your concern. The last assumption is that the predictions are made only within the range of observed value. That is pretty easy to understand. So, for example, we want to forecast the house price. Let's say, simply speaking, we use the property size to make the forecast of the house price, right? Property size, let's say, you collect the data in this community, okay, from 1,000 square feet to 3,000 square feet. Let's say that's your data set. You build a line, you say, okay, that's a relationship, right? For the very simple relationship, let's say the house price is x is a square feet times 100 size, property size. So for example, if you have the 1,000 square feet, that means $100,000, right? If you have 2,000 square feet, that's $200,000. Similar, 3,000 square feet, you have the estimated price is $300,000, right? So that's a very simple regression line. But now I have a question. Okay, you build this line based on the data from 1,000 square feet to 3,000 square feet. Now, your community build a luxury house. Okay, it has 6,000 square feet. Do you feel comfortable to use this formula you build to make this forecast for this 6,000 square feet luxury house price? Why you are not comfortable, Anna? or confident?
Because there's not a lot to compare it to. I mean, and because it's outside the normal range that we're dealing with.
Right.
A lot of other factors can affect how that house would price.
Right. Like the material. Well, if they build like 6,000 house, it can't be like cheap wood, right? There's no point. People buy 6,000 square feet with cheap material.
Right.
Doesn't make too much sense. Well, even you think about it, if the material or the cost is the same, but the margin of cost usually decrease when you build a bigger and bigger house, right? Given the same material, and usually like 6,000 square feet, probably they won't sell $600,000 or maybe a little bit cheaper. So the problem is here, right? We make this prediction, we should be within this range. So if the new house is like 2,500 square feet, which is good. We just plug them in. We are very confident. We use historical data to build this model. But if it's beyond range, for example, another example, if they sell a really tiny studio, like 500 square feet or 600 square feet, again, probably this model doesn't work very well. Right? It's probably a little bit expensive than we just plug in this model. Okay, so then you can see if you have some pattern like this, and nodes random, nodes normal distributed, and you need to pay attention. You have to re-evaluate your model, right? And also remember that's a comfortable zone area that you can use the model to make your forecast. There's a lot of things we need to consider. First, plus to verify. In fact, this is the initial verification. You see whether there's a linear relationship. Right? The data may be time dependent. Or then, if it's time dependent, you can use a time series model, like a linear trend model. Right? A small correlation may indicate that other variables are important, which means, okay, if you have R squared, it's very small. Let's say R squared is 0.3. Okay, you build this model, but R squared is pretty small. Then you may wonder, okay, maybe I missed some important factor like beyond the property size, like for example, number of bedroom, number of bathroom. So that's you want to add to improve this R squared. It's too small. Okay, that's the end of simple regression model. That's the end of all the models we want to introduce here in this chapter. How do you guys feel after 2 weeks? It's good? Overwhelming?
Overwhelmed a little bit.
A little bit overwhelming? Totally understand, right? I will probably post the homework this week, but the due date probably like, I will give you about 2 weeks. So you to prepare the homework. I also give you guys the tutor's information. Michael Smith, he's a very smart guy, very good at math. So just throw the math problem to him. No, he will try to help you guys for sure, include myself, right? Anytime you can come to office. Well, chapter 3, like I said, we have not finished. We'll talk about that a little bit. But chapter 3 include the most models compared to all other chapters. Like for example, chapter 13, inventory, will cover like 4 to 5 models. Well, but that's all. Well, chapter 3, we can count, right? From beginning. What's the first model we cover? The first one, the basic one, forecasting model. Anybody remember? First one, naive model, right? You are forget naive, so easy, right? Use the data last week to forecast data like next week, like Charles can be a very good weatherman, right? Next second, next minute's weather is so easy. Naive method. What's the next we have left? After naive method? Nobody is really here. Everybody think about hurricane, run away, preparation. After naive method, we go to the moving average. It's clear? Moving average is also easy, right? It's, let's say n equal to 3, that's last 3 pairs sales data, divided by 3, add net divided by 3, that's the forecast. After moving average, that's the extension of moving average. What's the name? Weighted moving average? Very good. It's weighted moving average, which means, okay, instead of just give the weights the same, well, we give more weights for the period close by, right? That makes sense, the weighted moving average method. And then what's next? The fourth method we have studied.
Smoothing.
Yeah, exponential smoothing method. We use the last period forecast and the last period actual data combined together to make forecast. An extension of this exponential smoothing method is called what? It's a pretty complex name. It's called trend adjusted exponential smoothing method. Fifth one, right? And I already skipped one thing. Is that linear trend method. That's sixth one. Number 6. Okay, now I see that in China we say 6 is this. But if I show that, nobody understand here. This is 6. But anyway, yeah. So the 6th method we say here, right? You guys say 6. Yeah, but in China we show all 10 numbers by one hand. So the number 6 is linear trend method, right? And number 7 we can think about is seasonality. This is number 7. If you go to China, you see people say finger. That's number 7. I don't know why it's 7, but yeah. Okay, the number 7 is seasonality. Number 8 is simple linear regression. Okay, that's what you think about. If we talk about seasonality has multiplicative or additive, that can be easily extended more than 10 models. But even we just count this big family, we have already covered 8 models. Well, I believe in many other classes, the whole semester you only cover 8 models, something like that. But here, in this forecast chapter, we cover all the models. Or the reason we cover this model, obvious reason is this textbook, right? They cover all the models, so I cover the model. But I have a friend, okay, more than 10 years friend. She's a faculty in a public university in Massachusetts. We discuss, we are in the same major, teach the same class. We discuss, she asked me what's the content I cover in forecast. And she said, why you cover like trying to just explain smoothing method? Why you do a lot of regression? She didn't cover that. She thinks it's too much for the student there. I think that their university is very similar to our university. So I believe student profile are also very similar. Maybe not as diverse as our campus, but I think for academic thing is very similar. But I told her, okay, I understand, right? Maybe some students feel difficult to capture all these models, right? But for me, my point is that I will teach the same amounts I teach here or any place else. For example, it's Purdue. In Purdue, definitely we cover all the models. Even maybe some more models depends, right? Because Purdue, every student is required for operation management business school. It's very, very important class. Very strong in this field. So I'm thinking about my student here. No matter where I teach, right? Even in the community college, probably knows this class, right? This is advantage. But no matter which school I'm teaching, you think about my students, you guys, after 1 or 2 years, right? You will go to the market, job market. You compete with all the students. No matter whether it's a similar university like FSU, Western Carolina, or top university, NC State, Chapel Hill, employee will look at you. Okay, what you have learned during the interview, during the project? What you have learned? You say, my teacher, he's a very nice guy, Charles, didn't teach us simple linear regression. Do you think it works? Nobody cares about me, right? And nobody cares why I'm so nice. No teach this class, this content. Nobody cares. They really want you to know that. Or even maybe you only know the notation or only know the formula, you are not able to digest in the beginning. But you at least know them. When you have an interview, when you assign this project, I know that, I will capture that quickly, right? So that's the reason I always cover the same contents in any class. But don't worry, first, in any university I do the same, right? I will help my students as much as I can. Second, I have to do the means. The exam difficult level here is a little bit lower than the exam level I post in Purdue University. So basically, content is the same, but I understand my expectation for every performance student here is different with like Purdue or research university. So you guys will have no problem, I believe, to pass this class, but also with all the knowledge you need to know. You really need to know in the future. I hope you understand, because I think many faculty has a similar philosophy. Maybe they don't explain to you guys, but I believe all hard faculty, you think, this faculty is so tough, will give us a hard time. You think about why. If we want to get a high teaching evaluation, that's very simple. I know some people did that. Well, just give student all A, right? So easy, everybody pass. Probably you will get very high teaching evaluation, but that's not the point, right? You can give us, like me, very bad evaluation, say, homework is so hard. But maybe you appreciate my efforts after 5 or 10 years. So that's my preference for long term. Right? But don't hesitate. We have the resource. We have tutor, myself, very smart classmates, lots of people, right? Okay, so ask them, ask me, and also challenge yourself. Right? You should be fine. Okay, next we're talking about how to monitor the forecast, right? So we introduce ACE model. There's lots of model. Okay, you test data sets, you build a model, and then are we done? No. You have to monitor your performance because, like I have told you guys, when I did the projects, okay, we spent 1 year to go live. So the first 1 year, then we do nothing but data collection, cleaning, test model, and train the customer. Finally, after 1 year, okay, you enable or for example, they use our model, run the engine every day. But that's the end of story, right? We have the after sales consultants. Basically, after sales consultant for the IT company is to monitor the performance, right? Anything wrong, you want to find that before your customer discover that. Right? For example, if your forecast accuracy keep decreasing for several weeks, well, like from accuracy from 80% to 6%, well, you should consider changing the model before your customer complain to you, right? So the same thing, when you take care of the forecast of your company, you want to monitor that. So you want to track the forecast error and analyze them, provide useful insights whether your forecast method are performing successfully. All right, source of forecast errors. The model may be inadequate. For example, we use a simple regression model, right? Which means we only have one variable here, right? X, right? Then we know that to make the forecast of the house price, only property size, probably is not enough, or at least not accurate. So that can be the problem why we are not doing very well. It can be another problem is the change or shift in the variable the model cannot handle. It's changed, right? During the recession, well, maybe like I said, these areas crime rates increase dramatically, and then location will overplace the size of property. So there's some shifts of a variable. Appearance of new variable. Right? For example, if we have a new school just built in our site, oh, that's a new factor. If that's the top school, right? That's also a shopping center. It can affect the housing price. So the new factor. Right? So when those happen, you have to monitor and modify your model. Well, also some irregular variations, random variations. Oh, that's we can't handle, but yeah, it's always there. The control charts are used to identify the presence of non-random error in forecast. The non-random item. Tracking signals can be used to detect the forecast bias. So this is a typical control chart. So how to compute the control chart? Let's say that. So first you can compute MSE. Still, anybody remember what does MSE mean? Nobody remember? Mean square error. It's one measurement of forecast accuracy. So you compute the MSE, and then estimate the standard deviation of distribution. S equal to the square root of MSE. Pretty straightforward. And then you can build these control charts. UCL means upper control limit. LCL means lower control limit. So it's 0 plus Z times MSE square minus or 0 minus Z MSE square. So well, Z is how tight you want to control your forecast. The bigger the Z, that means you have a loose control on forecast. You are pretty nice person, or to yourself, maybe to others. Let's choose Z equal to 5. Okay, that means this control chart is pretty wide, right? So if you forecast an error following this wide range, you think it's fine. But if you are a really tough guy, or you say, I want to control very close, you only allow Z equal to 1. That means your control has very narrow. Okay, so that is really your decision, or maybe your manager's decision. Choose the Z. But I can tell you, many in the reality, many company, many players they choose Z equal around 3, But it's really your choice. 3 is not the uniform correct number. Right? So once you get Z, you calculate MSE, you build this control chart like here. Right? Then we monitor our performance, forecast error. Okay, the period 1, we have negative, which means forecast is bigger than actual, right? And the period 2, a little bit positive, actual is little bit bigger than our forecast. But you can see all this 8 period is our forecast under control, out of control. Here. Do you think it's under control or out of control? This is the control chart, right? Lower control limit, upper control limit. For 8 period, do you think it's under control or out of control? Under control, Alan? Do you guys agree with Alan or no idea? Don't care. Just come here to attend class and then escape away. So, it's under control. Right? Because all the plots following this range, the blue arrow is the range, right? It's the control range. So you can see how we use this control. We build these control charts and we use this control charts to monitor that. But one thing I have to remind you guys, your control charts also lead to updates. Because think about it, you calculate MSE is based on historic data. After time period, you have new forecast error in the past time period. It's not required to update every week, every period, but you should keep that in mind. Or if you built a control chart half a year ago, probably it's not so useful to monitor your forecast. Clear? So that's the point. Okay. Factors to consider to choose the forecast technical. Now we already have 8 technicals, right? It's more than 8. Factors to consider, the first one is cost. Okay. If you are not working in a big company like P&G, Unilever, Shell, you don't want to invest $1 million on just forecast. They did that. They invest in different vendors, including my previous company, $1 million just for the forecast. Well, that's the reason, because they have like millions of products all over the world they will have to handle. 2% increase of the accuracy can create them more than $1 million profits every year, right? So that's the reason. But for the middle-sized small company, well, maybe you don't want to hire the consultant to do that. Charles is so expensive, right? I'm not expensive, but my company charged them $200 per hour. I didn't get that. So, but generally speaking, consulting is very expensive, right? IT company. Then what you can do, so you can use the Excel templates we'll provide in this class, the simple beginning step. But you can also build a model based on what we have teach you guys, right? But you can't balance the cost. You can also maybe have another choice is your teacher, right? Now I'm very cheap because I'm your teacher. Supposed to be kind of slave job to the free work for you. No, but anyway, you find the balance between your benefits and the cost. That's the most important thing. Right? Accuracy. Well, definitely, the more the better. We want more accuracy. But we know that's related to the cost. Usually, if you want to push accuracy from 80% to 90%, you have to spend a lot of money and energy. Right? Whether we have available historical data, this usually is not a problem for most US companies. For most US, but definitely some small company, right? You don't have historical data, or new products. There's no way you have you have historic data. But if you go to overseas, or maybe companies, the overseas side, you will see this problem very common. That's the availability of historic data. Because you think about developing country, many companies, they don't have these habits to collect the historic data. Well, at the beginning, when they come to the market, they just want to survive, might be successful. Okay, even after 10 years, they are very successful. They look back, okay, they didn't pay too much attention to keep the historic data in the past 10 years. That is creates a problem. So my suggestion is that no matter if you future work overseas or even here, open your small business, you want to have the habits as early as you can or convenience to collect the historic data. You put your personal laptop, right? That's still the historic data. Well, if without historical, you can see we can't do too much thing forecasting, right? And software again. Well, there's so many software, okay, in the market. Some are pretty cheap. I'm not sure. Yeah, we have the templates. If you call this software, I will share with you guys. The publisher probably you already have that. If you purchase the textbook. But for most software, they charge you some money. It's not like Excel. But you can still choose some cheap one or expensive one or medium range. Right? Time consuming. Right? Analyze data, get the data, prepare forecasts. Like I said, okay, when I did the project, usually we spend 1 year. Well, can you wait for them? They can wait. They are very patient. The reason they are so patient is because they know they have no hope to increase the revenue during the recession. They only hope to cut the cost. So they are very patient. When you do your job, 1 year, you go live, your projects, we cut the cost, they're happy. But that's for P&G, Unilever. For you, probably your manager only give 1 month for you. I read out 2 weeks maybe, but that's too tough. But maybe 1 month is reasonable once you like Sydney to get a good forecast, improve our forecast by 10% in 1 month. Then you have to choose. You can't say, oh, I will go through all 8 model charts and teach you guys, test each one and compare each one and monitor for 4 weeks, then give to you. That's too late, right? You'll probably get laid off right, by the time. So that's the thing you should consider, right? Time consuming. Forecast horizon, okay. We don't need to remind you guys again and again. It's so important and useful. If you can use the short-term forecast, right, compared to long-term. So push your collaborators, partners in other departments. Or maybe you work in other department, like in the finance department. You think about, okay, we have the user forecast so many years, like say 4 weeks forecast. But our forecast is not so accurate. This affects our financial budget. Can we push to 3 weeks? To 2 weeks. Okay, similar inventory, scheduling. If you, for example, many of you become a supervisor to scheduling. Do you really need like 2 months in advance to schedule? You can talk to your employee, okay, 2 weeks, is that acceptable to give advance notice? If you can use shorter horizon automatically, you don't need to invest any money. You get a better forecast. Clear? Okay, operation strategy, forecast is so important, right? To work to improve the short-term forecast because short-term forecast now is very useful. There are so many factors that can affect our forecast accuracy. For example, the fluctuation of our price, the demand pattern change, maybe some other important variable like hurricanes. Like I believe most of you guys or also has a lot of water stored in your house for a storm now, right? Because we prepare a lot, right? I guess like 4 packs of water, like 100 bottles of water, something like that. Well, I think I have to spend months to drink all of them, right? And also, my wife complained me yesterday evening because last Thursday I went to Target. I was so panicked to get water. There's no water in Target in Fairview. So I just passed by the bread shelf. Almost no bread. I didn't think, okay, I need to prepare the bread. So anyway, I grabbed the 2 of whatever. I didn't see the bread, I just grabbed 2. And it turns out it tastes so bad. Probably that's the reason they last the last. So. but anyway, so my wife, I already made a mistake. I promised her I eat 2 bread this morning, 2 bread in the evening. I forget this morning. That means I have to eat 4 bread this evening. So, but anyway, so you can think about all these variables from price, from demand, from hurricane, from all those things can change our pattern. Then when this happens, okay, unfortunately we have to modify our forecast. So anybody wants the very best taste bread, let me know. I can share with you guys. So if we can reduce the time horizon, again, right, we can improve that, right? Supply chain collaboration, right? For example, if we have more information from our partners, that can improve our forecast. We'll discuss that in the chapter 15. But anyway, that's the end of chapter 3. Any question, comments, or complaint? Only complaint, right? Okay. I would say, okay, silence means it's acceptable, right? Hopefully. Okay. Now, I think you guys can't wait to come to the next chapter. I do the same, right? Because I can tell chapter 5, we only have 1 example with math. It's just some number divided by another number. That's all the math we have for chapter 5, right? Elementary school. So you guys you will have a little bit comfortable time in this chapter. But it's still a very important chapter for the capacity planning. We'll look at first, what are the learning objectives? So in this chapter for the capacity planning, well, first think about 3 key questions for capacity planning. Well, explain why it's important. Okay, you will say because you cover that. So we have the homework exam. Well, that's not the reason why it's important, right? Ways to define and measure the capacity. What is the effective capacity? Factor to consider when deciding whether to do it in-house or outsource. This very hot topic in the past 10 or 20 years. Do it in-house or outsource? Major consideration related to developing the capacity alternative. There's so many methods. Think about if you want to increase the capacity. Right? There are lots of things you can do. Right? Think about, let's say you work in the manufacturing company. Okay, you can't satisfy the customer demand. You say, okay, I have to double our capacity. What you can do? Anybody? In the manufacturing company, you want to double your capacity, double your production units every day.
Well,
What kind?
Well, you need to, I guess, double your resources.
What kind of resource, please?
Machinery.
Machine, very good. Suddenly, buy another machine, buy an advanced machine, upgrade the machine, right? They can produce. Anything else we can do?
If you only have one shift, you can go to multiple shifts. You can go 24 hours instead.
More
of-
people, right? Have more people, right? Another thing, right? And something else we have already outsource, right? You can't do that, so you outsource them, right? But there are so many alternatives. We have to think about which one is best for us. Maybe the combination of several different methods, but that's we have to consider, right? For example, how the people versus outsource. That's totally two different ways, right? How the people you have the good control, but on the other hand, okay, in the future, if your demand goes down, can you lay off them? Probably it's pretty tough to lay off them, right? Outsourcing, the problem is quality controls problem, and also long term, maybe you lose the opportunity to grow, right? Because that's a good chance if there's a stable increase in demand. Steps used to resolve the constraints issue and describe the approach useful to evaluate the capacity alternatives. So the capacity by definition is the upper limit or ceiling on the load that an operating unit can handle. So capacity include, we have discussed equipment, I see the dimension, machine, space, employee skill, more people or more skilled people. So either way will work, right? Strategic capacity planning. The goal for the strategic capacity planning is to achieve a match between the supply and the demand. Well, there's nothing new, right? We have this equation is here. From the chapter 1, okay, that's our goal. Supply equal demand. We spend the whole semester on this equation, or approach this equation. The forecasting, we know if we approach that, it's 100% accurate. It's almost impossible to get 100% accurate forecast. But that's our goal, right? To match the supply with our demand, from forecasting, from capacity. Okay. But here, pay attention. There's no simple supply match demand. It what? Long term. Pay attention here. Why is specified long term? Operation manager would do nothing but to match supply with demand. Why for capacity planning we consider long term match, not short term, not medium term? Why? For the capacity planning for this chapter, our target is to match them in the long term, by years. Not I don't care next week or next month. It's not our consideration. Cost.
Maybe to see the progress.
Progress,
over the years.
cost, both are correct. So first, okay, see the dimension, guys. If you change the capacity, it's not easy. It's not like a forecast. You do the paperwork, right? You run the model again, you change that. But capacity, you order the machine today, probably they need like half a year to give you this machine, right? It can't happen immediately. Second, like Adam said, right? The cost. Capacity is so expensive to change. You think about it, from the machine, from space, from employee. It's not easy. It's not like you have like 2 temporary workers. Right? We don't think it's really capacity change, right? It's just cover some leaving employee. But when we talk about capacity change, right? Have a lot of new people or lay off a lot of people due to outsourcing, buy a new machine. they are very expensive. When we make big investments, definitely it's not a short-term investment. We can't change. We don't want to change after another half a year, right? When we change the capacity, for example, Walmart, if they expand their space, that means over several years they see the demand increase. Otherwise, why you want to expand, right? So, capacity is really for long term. Okay, then you can see what we have just finished for the forecast. We talk about, okay, if our departments, okay, they can use our short-term forecast, when we benefit, we get a better forecast accuracy. But here, for some departments, they cannot, like capacity. They cannot use short forecast. We understand, right? You can't say, oh, you guys, so you always use like Lexia's forecast. That's the reason you guys sucks. Look at that. No, they have to use Lexia, right? So, well, then maybe they suffer, but no, their problem. They are assigned to the capacity planning, right? You are doing schedule, you can use 2 weeks to tell employee. They can't tell they are, okay, 2 weeks, you get 100 people to work on site in 2 weeks. No way to do that, right? So, we see that constraint. We talk about good ways, okay, free way to improve our forecast error. But again, that's the constraint. It's really depends on the different department, their requirements, right? Two type, over capacity, cost too high. Under capacity, that we lose customer. Again, right? Supply greater than demand or supply less than demand. Almost impossible to reach this equation. Though it's our goal, right? So the questions. 3 questions for the capacity planning first. What kind of capacity is needed? How much is needed? And when it is needed? Some related questions include the cost of potential benefits risk, sustainability, capacity change at all once or small step, kind of supply chain handle that, even you change your capacity, whether the transportation, your downstream, or your supplier can satisfy your increase in capacity, or something like that. Okay, let's think about the example to consider these questions. Think about UNC Pembroke. So what's happened the next fall? Do you guys, what's happened for our campus next fall? 2018 fourth semester?
Price goes down.
Yeah. NC promise. That means the TUE fee goes down. I know many of you complain because you are graduates. So you can wait until you benefit, but probably don't want to wait, right? But you think about it, okay. So what's happened? If we decrease our tuition, we get subsidy from the states, but then what's happened?
Demand goes
Demand
up.
goes up.
Demand goes up, right? We expect significant increased demand. Well, that's the expectation of the governors, right? Why they want to subsidy your university and also to other university to cut the cost? Because they want you guys to teach more students. Or you can't say, oh, I still do the same 6,000 students. Oh, no. They will be very angry about that. So, fortunately or unfortunately, or by ourselves or by the external force, we have to have more students, most likely, right? Let's say we increase our people, right, demand from 6,000 to 8,000 in 2 years. Then that means we have to adjust our capacity. I don't think the capacity is enough here, right? Then, okay, if we increase 2,000 students in this campus, you guys can't imagine, right? Then, what kind of capacity we need in the university? Hard question? University, what capacity we are talking about? It's not a manufacturing, it's not a retailer store. For this university, when we talk about capacity,
For students and faculty.
a student is, I think, is the demand. Yeah. Faculty definitely is a capacity. For more faculty or faculty teach overload, something like that. We already teach overload. But anyway, faculty. Anything else for the university?
Class size.
Classrooms. The size of classroom and also more classrooms. Right? Good. Anything else? Dorms. Right? Dorms. Right?
Parking.
Parking. Yeah. Finally, Adam mentioned something. Everybody agree. Parking. Parking is horrible recently. Well, 5 years ago I came to US Family. I remember 2012. Well, I came the first day of the semester. I think it's very busy. But it's easy to find a parking space. I told my colleague, oh, I like this small university. Compared to Purdue, it's headache to find a parking place. Well, we have 6 floors, garage. And many times I have to go to the 6th floor. It's 6th floor is the outdoor, right? There's no way to get the first 5 floors, so I have to drive the car to the 6th floor. That's in Purdue. We have like 4 garage like that. Wow. So, but here, and then, okay, in the recent 2 years, I begin to complain, right? Especially at the beginning of semester, some freshmen, they don't care, they park in the faculty place. Well, I simply can't find a parking place last semester. I remember, I came here 10 minutes. I feel sorry for myself. I told them I came to school 15 minutes before the class. It took me 25 minutes to find a parking space. Yeah, so I can't imagine if we increase 2,000, especially freshmen, then what's happened, right? So anything else? So parking, dorm, faculty, classroom.
Cafeteria.
Cafeteria, very good, Dylan. I still kind of like of cafeteria, right? It has a different food, but I heard a lot of complaint too from our students. Probably you guys eat every day. I only eat like once per month, once per week. So probably that's the reason I'm okay, right? But definitely it's a capacity problem, not just taste, but also the capacity itself, right? And also think about, okay, after NC promise, out of states tuition also decreased dramatically. The amount is even more than in-state tuition, right, for out-state. So that means we probably will have more out-state students and international students. Then for the cafe, you think about, right, you need more diversified food, for sure, right? Not everybody like the southern type of food. I'm still not getting to southern because, for example, like the first year I came here, I attended a conference in Charleston. I went to Charleston. Okay, Charleston is a great city. Okay, I learned a lot of history about Civil War after visiting Charleston. But anyway, so I Googled that, so TripAdvisor, Yelp. That's say downtown Charleston is very good seafood restaurant. I believe Charleston is in the close to the sea, right? The seafood must be delicious. I went to that seafood restaurant. It's baked. It's all fried. Fried shrimp. I say, it's seafood, right? So it's fresh. You are so close to the sea. Why you want to fry them? I can't tell whether you already frozen them for 1 year or just got that yesterday. Right? You guys, many of you are southern, right? This is the culture, right? But why we can't just eat fresh seafood? This is the best seafood restaurant in Charleston. They give me fried shrimps. But anyway, and I went back to here. So that's a difference, right? So you think about the capacity, not just the size, classroom size, but we have to satisfy the different demand type, right? International students or student need additional help, right? The student has some disabilities. Okay, if we have more students like that, we have to modify our capacity. And how much is related to our forecasting, right? You have the forecasting and then you calculate how much. When is it needed? For example, UNCP definitely we will not next fall we increase 2,000. There's no way we can accept that because we can't handle, right? Even we have to increase 2,000, everybody understand maybe 500, step by step, want to reach like 8,000, right? But some people think we will have 10,000. I can't imagine 10,000. That I have to come to school 6:30 to get a parking place, right? Or ride a bike to school. Too far. Festival to here, like 4 hours riding bike, right? So the capacity, okay, the when it's happening is also important. Think about, you know that for sure UNC Pembroke will have more students. But that's not the end of your solution. When you talk about capacity, you need to know exact time. When do you need that? When do you need the parking lot? More dorms, okay. Cafeteria, more dish, more choices. That's the problem, right? So it's not easy, especially think about the information we have is long-term forecasting, long-term financial budget, long-term a lot of things, which means in this long-term, anything can change. Or the demand pattern can change, your budgets can change, your people can change. And then it's make capacity planning extremely hard. So that's the reason we need to be very careful. We know it's hard, it's not easy. Think about UNC Pembroke. I can tell you, you guys, you are students, you will graduate very soon, so you probably don't worry too much about that. But I can tell you, many faculty has a big concern of this NC promise. Because obvious reason, we won't get any salary increase because of that. But definitely we'll teach overload or actually more students each session. Right? Some students should also have concern, right? If the class size increase dramatically, like now it's like 30 to 50. Are you comfortable to stay in this class on 50? It really depends. I can tell you, when I teach in Purdue, every time more than 50 students. Every time, every semester, 50, 55. Exercise. My memory is not very good. You guys know that. That's why I work around. So in Purdue, it's take me 1 semester to remember everybody's name, and then it's finished because there's so many people, right? So, but here, when class size increase, it will affect every student, existing one or new student. Everything is affected. Parking lots, right? So it's not easy. Okay, but anyway, we'll talk about how we can make a good decision of capacity planning next class. See you guys. Wednesday.
Slide.